Welcome to Simpliphysics. In this video, you will learn about a few simple effects of refraction. A set of pens viewed through a glass slab seems to be broken. Similarly, the body of a person standing in a pool seems to be cut into two halves when seen through a specific perspective. Both these observations are on account of lateral displacement, an effect of refraction. Consider an object upon which a glass slab is placed. A ray of light, traveling from the object through the glass slab, takes the refracted path. However, to the person watching the object, the ray seems to have taken a straighter path. Therefore, the object seems to be laterally displaced from its actual position. To understand lateral displacement in some more detail, let us consider the behavior of light through a glass slab whose thickness is T. A ray of light incident on the upper surface of the glass slab travels through the glass slab and emerges out of its lower surface, with the angle of emergence, E. The projected incident ray is then parallel to the emergent ray. The perpendicular distance between the projected incident ray and the emergent ray is called lateral displacement, L. Let us now investigate the factors that affect lateral displacement. Of two glass slabs, the lateral displacement is greater for the thicker glass slab. Hence, lateral displacement is directly proportional to the thickness of the glass slab. If the glass slabs are identical, but the angles of incidence are different, the lateral displacement is greater for a greater angle of incidence. Hence, lateral displacement is also directly proportional to the angle of incidence. Of two glass slabs with different refractive indexes, the lateral displacement is greater in the glass slab that has a greater refractive index. This means that the lateral displacement is directly proportional to the refractive index as well. However, if the glass slabs are identical, but the wavelengths of incident light are different, the light that has a greater wavelength suffers lesser lateral displacement. This means that the lateral displacement is inversely proportional to the wavelength of incident light. That was lateral displacement. Let us now look at the next effect of refraction. The phenomenon of refraction also causes the apparent depth of water bodies to be lesser than their real depth. For example, a swimming pool filled with water appears to be shallower, and the body of a person standing inside the swimming pool appears to be shorter. To understand how this happens, consider a coin placed at the bottom of a vessel filled with water. A ray of light that travels from the coin bends away from the normal to meet the observer's eye. However, to the observer, the light ray seems to have taken a straight path. This causes the coin to be placed at an apparent depth that is lesser than the real depth. This diagram shows why the legs of a person standing in a swimming pool appear to be shorter. It can be proved that the ratio between the real depth and the apparent depth is equal to the refractive index. Since the refractive index of water is 4/3, the apparent depth of an object in water is always 3/4 the real depth. Similarly, the depth at which an object kept under a glass slab appears is always 2/3 the thickness of the glass slab. Next, let us look at one of the most classical effects of refraction. When an object such as a straw or a pencil is dipped in water, it appears to be bent. Let us understand how this happens. Consider a stick kept in an empty vessel. When the vessel is filled with water, the stick appears to be bent. This is because light appears to have taken a straight path, despite being refracted when it goes from the tip of the stick to the eye of the observer. And now, the summary of this video. Refraction is responsible for the phenomenon of lateral displacement. The perpendicular distance between the incident ray and the emergent ray is called lateral displacement. Refraction causes the depth of water bodies to be lesser than their real depth. The ratio of real depth to apparent depth is equal to refractive index. Refraction also causes objects dipped in water to appear as if they were bent. That's all about some of the most simple effects of refraction. In the next video, you will learn about a few advanced effects of refraction.